Dinosaurs are one of the most popular groups of extinct animals that we study, maybe second only to, well, us. And despite having lived hundreds of millions of years ago, they still captivate our imaginations today. From their imposing size and strange appearances to the dramatic events that led to their extinction, there's just something about these ancient creatures that we can't stop thinking about. One thing we often think about when it comes to dinosaurs is how warm or cold-blooded they were, which is not what you think. Let's dive into this week's Dino Debate. Were dinosaurs warm-blooded? First up, let's define our terms. When we say warm-blooded, we're talking about animals that can regulate their own body temperature like we do. This means maintaining a stable internal temperature regardless of the environment. On the other hand, cold-blooded basically means the opposite. These animals rely on outside sources of heat to warm up, such as the sun, and they have no way to maintain a constant temperature. In general, we tend to associate being warm-blooded with being more active and dynamic, and cold-blooded with being slow and sluggish. For example, some cold-blooded animals like crocodiles are pretty quick in short bursts, but they can't sustain that activity for long periods of time. Meanwhile, some warm-blooded animals like sloths are notoriously slow. Being cold-blooded has the advantage of conserving energy. Since you don't have to expend energy maintaining a body temperature, you can get away with eating much less. However, the downside is that you can't be active unless you're warmed up. And if you live in a place where it's consistently cold, then you'll be cold all the time. Being warm-blooded makes it so that you can be active at any time of day or night and in any location. But that comes with the cost of expending more energy and needing more food than cold-blooded animals. So knowing this, what kind of animals were dinosaurs? Well, like with so many things in paleontology, the answer is complicated. For most of the 20th century, scientists assumed that dinosaurs were cold-blooded since they lived during the age of the reptiles, which we now know were overwhelmingly cold-blooded. The idea of dinosaurs being warm-blooded didn't gain any traction until 1970, when a scientist named John Thomas published a paper outlining his belief that dinosaurs were endothermic, the technical term for being warm-blooded. Thomas noticed that the bones of dinosaurs like the sauropods had very thin walls, which meant they likely grew out of their shells at a faster rate than if they were cold-blooded. Cold-blooded animals typically have thicker walled eggs, since this provides more protection against predators. So, if dinosaurs were cold-blooded, they should have spent a longer period of time developing inside their eggs. But based on bone structure, it seemed that they hatched much quicker. Therefore, dinosaurs must have been warm-blooded. But over the next few decades, other scientists argued against this idea, pointing out that dinosaurs were reptiles and that all reptiles are inherently cold-blooded. They also pointed out that fossils of baby dinosaurs often show signs of being laid horizontally in nests, with adults occasionally sitting on them to keep them warm. If dinosaurs were warm-blooded, why wouldn't they have sat up on their eggs instead of laying them down? Even so, the debate continued, with studies showing that dinosaurs likely did not shiver, which is something that cold-blooded animals do to generate heat. But even this evidence wasn't enough to sway the scientific community one way or the other. Now enter the year 2014, when paleontologists found the fossil of a relative of Ankylosaurus in Canada. This animal, called Borealopelta mark Michelli, was a large reptile that lived around 75 million years ago, and unlike most reptiles, it appears to have been warm-blooded. This discovery helped researchers figure out that there was actually a genetic mutation involved in making this animal warm-blooded. And after discovering this, scientists began to wonder whether or not dinosaurs had a similar mutation. One of the main pieces of evidence for this came from studying dinosaur eggs. Cold-blooded animals often lay eggs with shells composed of calcite, which forms in a more horizontal orientation. Warm-blooded animals, on the other hand, usually lay eggs with shells made of aragonite, which form vertically. When looking at fossilized eggs from different kinds of dinosaurs, scientists noticed that most of them had a mixture of both, suggesting that they were mostly cold-blooded. But some, like the ones left behind by oviraptors, were predominantly aragonite, suggesting they were warm-blooded. Then in 2019, scientists decided to look at preserved proteins from dinosaur eggs to finally put this debate to rest once and for all. After comparing proteins from dinosaur eggs with those from modern birds and reptiles, they concluded that dinosaurs were indeed warm-blooded. The study's author said, "It was really exciting to find direct evidence for dinosaurs being warm-blooded because it's been a subject of debate for so long. And our results support the idea that dinosaurs were warm-blooded and therefore related more closely to birds than to crocodiles." So there you have it. we can finally put this debate to rest, or can we? Well, there seems to be one dissenting voice. A 2023 study claims that some dinosaurs may have actually been a mix between cold and warm-blooded, allowing them to thrive in a variety of environments. This is called being poikilothermic, and it's seen in some fish, amphibians, and reptiles today. These animals can adjust their metabolic rates depending on the environment, which allows them to survive in a wide range of climates. But this isn't the same as being truly cold-blooded or warm-blooded. Instead, it's a combination of the two, allowing the animal to take advantage of both. The study states that dinosaurs were most likely poikilothermic, saying that previous research, including the protein analysis from 2019, was misinterpreted. The authors wrote, "The findings presented here challenge the prevailing view that dinosaurs were unambiguously either endothermic or exothermic. Instead, we show that the physiological state of dinosaurs was more complex and allowed them to exploit a broader range of ecological opportunities than previously thought." They argue that certain adaptations in dinosaurs like feathers would have been better suited for regulating their body temperature as needed rather than always maintaining it at a steady rate. Basically, the evidence suggests that dinosaurs could turn their temperature regulation on and off, allowing them to thrive in a variety of habitats. If this is true, it makes sense why dinosaurs were able to become so successful. By being able to conserve energy when needed, they could survive in times of food scarcity and boom in numbers when food was abundant. This flexibility may have given them the edge they needed to outcompete other animals during the age of the dinosaurs. So are dinosaurs warm-blooded or cold-blooded? Well, truth be told, it's somewhere in between. Even though dinosaurs were likely predominantly cold-blooded, they had adaptations that allowed them to be warm-blooded when necessary. This means that dinosaurs didn't have to stick to a certain climate or behave in a certain way to survive, giving them the freedom to explore new habitats and lifestyles. In the end, dinosaurs were able to conquer the world because they didn't have to conform to a single way of living. Now that we know more about how dinosaurs' body temperatures worked, does anyone else feel like there should be a new group called the mesotherms? I mean, that's better than cold hollow beak-toothed lizard, right? Thank you for checking out Dino Debate. If you liked this episode, make sure to leave us a like and comment below with your ideas for future episodes.